Okay, so in today's lesson we're going to be looking at linear systems, or more specifically we're going to be looking at how to graph linear equations of the form y equals mx plus b. Okay, but first, before we can graph equations, we need to look at our coordinate system or coordinate plane. So just as you can represent real numbers by points on a number line, you can also represent an ordered pair, so points x, y, by points in a plane called a rectangular coordinate system or a rectangular coordinate plane. So we've looked at number lines before. This runs in one dimension. A rectangular coordinate system or rectangular coordinate plane runs in two dimensions because we have an x coordinate and a y coordinate, and we can go in a lot more directions using this, and we can graph linear equations. So given this, we have our grid. We're going to draw two lines, one horizontally and one vertically in the middle. The vertical axis is called our y-axis, and the horizontal axis is called our x-axis. And where these two axes meet, the middle point is called our origin, and it has a coordinate of 0, 0, where x is 0 and y equals 0. So in our top right quadrant, or quadrant 1, it has all values for its coordinates are going to be positive. Because if you move right, like we've seen on number lines, when you go right, x is positive, and when you go up, so vertically, similar to our number line, when you go up, it creates a positive value, and when you go down, it creates a negative value. So in quadrant 1, both values are positive. Now, from here, we're going to be going in a counterclockwise direction. So we'll be moving left to our top left quadrant, so quadrant 2. So in quadrant 2, our coordinates for x are negative, and our coordinates for y are positive because we're going left and up from our origin. And then continuing along, we get to quadrant 3, so in our bottom left quadrant, it has coordinates that are both negative, so x is negative and y is negative because you go left and down. And lastly, our bottom right quadrant, or quadrant 4, has coordinates that where x is positive and y is negative. Okay, so now that we have our coordinate plane, we can use this to graph ordered pairs that have coordinates x and y. So we want to graph the following ordered pairs. So our first point A has coordinates 0, 0. Second coordinate B has coordinates 3 and 2. Third coordinate C has coordinates negative 3 and 1. Our fourth coordinate D has coordinates 2 and negative 3. And our last coordinate E has coordinates negative 3 and negative 4. Okay, so we need to draw ourselves a nice little coordinate plane, and we already know that coordinate A has in our origin because it has coordinates 0, 0, so that's where point A goes. Point B has an x coordinate of 3 and a y coordinate of 2, so it's going to go to the right 3 and up 2, so this is point B. Point C has an x coordinate of negative 3 and a y coordinate of 1, so it's going to go left 3 and up 1, so this is point C. And point D has an x coordinate of 2 and a y coordinate of negative 3, so it is going to go right 2 and down 3, so point D. And lastly, point E has an x coordinate of negative 3 and a y coordinate of negative 4, so it's going to be in our third quadrant, and it's going to go left 3 and down 4, so point E. Okay, so we have linear equations in the form of y equals mx plus b. Now, this linear equation in this form is also called the slope-intercept form. So this is our general equation for a line in this form. Now, looking at this equation, there are some variables that can be defined. So the first variable we're going to look at is m. So m represents our slope. So our slope defines how steep our line is going to be, whether it's facing up or down, going from left to right. And it can also be defined as the rise over the run. Now, if you're given 2 points on your line, you can also define it as y2 minus y1, where these are your y coordinates of both your points, over x2 minus x1, where these are the x coordinates of your 2 points. Now, the order you have these in doesn't matter as long as you keep them consistent for your first point and your second point. And lastly, our constant b gives us our y-intercept. So whatever value this is, wherever your line crosses the y-axis, that is going to be the value of your y-intercept. Now, this also occurs when x equals 0. So whenever we have x equals 0, you know right away that wherever your y value is, that is going to be your y-intercept. Okay, now we can start graphing some linear equations. But there's more than one way to do this. So let's look at method 1. So in our first method, step 1, write your equation in the form y equals mx plus b, or slope-intercept form. Step 2, you're going to plot the y-intercept or any other known points. So we know that the y-intercept is defined by our b value. Step 3, you're going to travel up if the slope is positive, or down if it's negative, by the distance given by the rise. Then you're going to travel right a distance given by the run, and then you're going to mark this new point. Once you have your 2 points, all you need is 2 points to draw a line, so you're going to connect these 2 points together and then extend it in both directions. You're almost done. Once you've extended it, then you're going to add arrows to both sides. This shows that it goes on forever in both directions. Because if you just have your 2 points connected by a line, this is just a line segment, and it is not, it'll show that it's not going to go on forever in both directions, unless that's what you want. Okay, so using this method, we're going to graph the following linear equation. So we're going to graph y equals negative 2/3 x plus 2. Alright, so let's fill in some values. So first, we want to look at our y-intercept. So our b value, in this case, our constant is plus 2. So if we go along our y-axis and find plus 2, that is going to be our y-intercept. Now from here, we want to look at our slope. So our slope is negative, so we know it's going to go down from left to right. And our slope m is negative 2/3, which is our rise over our run. So our rise is negative 2. So from our point on, from our y-intercept, we're going to be going down 2, and our run is 3, so we're going to be going right 3. And this will give us the location of our next point. And since we have 2 points, we can now take a ruler and we can draw our line through these 2 points and extend it in both directions. And this is the graph for our linear equation. So our linear equation y equals negative 2/3 x plus 2 can be defined by this graph. Now, we're going to also look at this using another method. So in the second method for graphing linear equations, step 1, just like before, you can write your equation in the form y equals mx plus b, or slope-intercept form. Step 2, it's going to be a little bit different now. You're going to pick 2 values for x that are divisible by the run. And as we've seen before, our run is the denominator of our slope. Now, if your slope is given by a whole number, you can turn this into a fraction by putting it over 1. and then that 1 in this case would be your run. Step 3, for each value of x, you're going to solve it for y. And then lastly, step 4, you can plot your 2 points and then draw a line through them. Okay, so we're going to look at the exact same equation as before, except we're going to try graphing it using method 2. So step 1, write your equation, got that. Step 2, we need to look at our slope. So our slope is defined by rise over run, which is -2/3, but now our denominator is 3. So what we need to do is find 2 values that are divisible by 3. Now, for the first one, I'm going to pick x equals 0. Now you might not think it, but 0 is divisible by 3, because if I take 0 divided by 3, it gives me 0. 0 is a nice number in this case. And this can work for any numbers except for 0 itself, because 0 divided by 0 will not work. But one of the reasons for picking 0 is that whenever you take 0 and times it by anything, it just becomes 0 and goes away, so 0 is a good number to pick. Now, another number we can pick is 3 itself, because 3 is divisible by 3 and goes into itself once. And when you're picking points, you're better off picking points that are smaller, because it'll make your math a little bit easier. And you don't necessarily have to pick points that are divisible by 3, but when you do this, it'll make the mental math much easier, and you'll get nicer numbers, and you won't get decimals. Okay, so first we're going to look at x equals 0. So I'm going to plug this into my equation. So wherever you see an x, I'm going to replace it by 0. So we're going to have y equals -2/3 times it by 0, and then add 2. So whenever you times anything by 0, that part can just disappear because it's 0. So all that we're left with is y equals 2. So when x equals 0, y equals 2, so these are the coordinates for our y-intercept. Now we're going to do the exact same thing, except we're going to use x equals 3. So wherever you see an x, replace it with 3. So y equals -2/3 times 3 plus 2. Now, since we have 2/3 and timesing it by 3, the 3's can divide each other out and essentially just disappear. So we're left with y equals -2 plus 2. And then these two numbers nicely cancel each other out, so we're left with y equals 0. So when x equals 3, y equals 0. So this is the coordinate for our x-axis. Now that we have 2 points, we can draw a line and graph these. And as we can see, this is the exact same graph as before, so we know that these two methods give us the same result. Alright, now let's look at another example. Let's say I want to graph y equals 3/4 x minus 2. Now, this is just my preference. As long as I'm given nice numbers for my slope and y-intercept, I prefer to use method 1. So, given our equation, first thing I need to do is find my y-intercept. So looking at my b value being -2, that is my y-intercept, so go down 2 spots from the origin and we'll have our first point. Then we need to look at our slope. So our slope m equals 3/4, which is our rise over our run. So from our point, what we need to do is go up 3 and to the right 4, and this will give us the coordinate for our next point. So I go up 3, right 4, now I have 2 points for my line. So all I have to do now is draw a line between the two, extend in both directions, add some arrows, and we have now nicely just graphed our equation for y equals 3/4 x minus 2. So when you see linear equations at first, they might seem confusing because there's lots of variables and unknowns, but as long as you follow the methods for method 1 or method 2, graphing linear equations can hopefully for you be quite easy. And nowadays with software, this can be done much easier using graphing calculators, smartphones, computers. But being able to do it by hand is a handy skill, and it just makes you understand the math that much more. Okay, hopefully now you can go try this yourself and graph some linear equations.